Okay, we're going to do Unit 6, Day 3. We're going to talk about adding and subtracting radical expressions. Yesterday we multiplied and divided. And then we're also going to, on the back side, talk about how to rationalize denominators, because we never want to have a fraction where there's a radical in the bottom of the fraction. So learning targets, I can add or subtract nth root, so any root, could be square root, cube root, fourth root. I want to try to be able to add these, and then I can rationalize the denominator when appropriate. Now the big thing here, when adding and subtracting radical expressions, the two expressions have to be like radicals, meaning they have to have the same root. Just like when we're multiplying, if you want to combine them, they have to have the same root. Well, here they have to have the same root and the same number underneath. Okay. So if the two expressions are like radicals, meaning they have the same root and same radicand. Radicand means what's under the root. So like on this one, the root would be 2, the radicand would be 3 underneath. So what's inside there? So if they're the same, then combine the coefficients. It's almost like when we're adding like terms. If you have an x plus 2x, well, that's 3x. But if you have an x plus a y, that's just x plus y. You can't combine them. So think apples and oranges. They got to be the same thing to combine them. So here, 9 radical 3 plus 2 radical 3. What we're really doing is we're factoring out a radical 3. So take a radical 3 out front. It's just 9 plus 2 then. And 9 plus 2 is 11, so it'd be 11 radical 3. We don't do the factoring. We don't have to do all of that. We don't have to do radical 3 and then 9 plus 2, and that equals 11. You can just say, well, if they have the same, they're like radicals, same root and same radicand, so they're both radical 3s, square root of 3s. 9 plus 2 is 11. So here I've got, look at this. This is the square root of 2x. That's a square root of 2x. That means I can combine those, the 5 and the 2. Again, what I'm really doing is I'm factoring these out, and I have 5 minus 2 left over. But so 5 minus 2 is 3, and then they both are being multiplied by a radical 2x. And nothing to do with radical 2x, no simplifying with that one. Here I've got a cube root of y and a cube root of y. One's being multiplied by 14, one's being multiplied by 3. And I'm subtracting, we'll just do 14 minus 3. That's 11, and then cube root of y. That the cube root of y doesn't change. The radical 3 doesn't change. The radical 2x doesn't change. Just like when you're adding like terms, you add the coefficients, and then everything else stays the same. Now you look at this guy, and you think, well, can't do anything with it, better move on. But could I simplify it so they do have the same radical? Because the square root of 200, that's not simplified all the way. So 200, I'm just going to go put my factor tree right here and save a little bit of space. It'd be what, 2 and 100, 10 and 10, 2 and 5, 2 and 5. So looking for pairs of things, I might choose these two, just be easier. But don't forget this 2 out here. So here's a pair of 2s. Here's a pair of 5s. So I take a 2 out and a 5 out, that's 10, and I got a radical 2 left underneath. So the radical 200 is the same thing as 10 radical 2. Now 72, 9 and 8, 3 and 3, 2 and 4, 2 and 2. Look for pairs, pair of 3s, pair of 2s. Take a 2 out, take a 3 out, 2 times 3 is 6, and then 2 is left under the radical. And now they are the same. 10 radical 2 minus 6 radical 2 would be 4 radical 2. So it was possible to do that. So you want to simplify both these as much as possible before you kind of throw your hands up and say, I can't do anything with it. Because a lot of times you'll be able to do something with it. Cube root of 3, I can't do anything with that. That's simplified all the way. But 81, I could factor that. So 9 and 9. Now I've got 3 3s here. Because for every 3 you can pull 1 out. So I'm going to pull a 3 out front. And then there's a cube root of 3 left underneath. Minus 3 cube root of 3. Well, they're the exact same thing, so that's 0. And over here, again, if you want to try to pause it here, try this one out, go for it. Maybe quiz yourself. So I'm going to simplify both of these. So 32 would be what, 2 and 16. So looking for pairs. So here's a pair of 2s. Here's a pair of 2s. 2 times 2 is 4, times the 3 that's out front already is 12, and then you got a radical, you got a 2 under the radical still, plus, and then this would be 2 and 25. Again, pairs, I got a pair of 5, so pull 1 out, and then so the 5 times the 2 that's already there would be 10, and then I got a radical 2 left underneath there. So 12 plus 10 is what, 22 radical 2? Okay. So maybe we'll pause. Pause the video, try these out. I do want to try these out. I'm just going to put the answers down just to save some time in the video. I think we're kind of seeing what's going on here. But for 7 and 8, try 7 and 8. See how you do on this. Okay, so I did those two. They worked out. They ended up being all like terms. Down here, this guy, again, I think we're kind of getting the simplifying part, so I'm going to jump ahead. I'm going to say this simplifies to 12 radical 10. If you want to check yourself, you can see if you did it. See if you did it right. And then this one would be 6 radical 10. And then this would simplify to 15 radical 6. So I'm looking at this. I can combine these two like terms. So 12 minus 6 would be 6. So 6 radical 10. But the 15 radical 6, nothing I can do with that. So I'll just circle that as my answer. That's as simplified as I can get with that guy. Now the back side, I'm kind of changing a little bit. This is rationalizing. Now you could throw this in. We could have thrown this in with dividing, because we're actually dividing. It's a fraction. It's radical 15 divided by 5, radical 20. But we want to talk about really just what's wrong with it is I can't have a radical in the denominator. We don't like to have radicals in the bottom. It's just not an appropriate way to write an answer. Much like, I wouldn't leave a fraction as 5/10. That's improper. I need to reduce it. Well, here I need to fix this. I need to make it something that's acceptable. Now, what's the problem with this is the radical 20. Okay. I'll also say too, there's a few routes I could take. I could actually simplify radical 20 first, because I could take a 2 out of there, because this would be 2 times 2 times 5. I could take a 2 out and go from there, but I'm still going to have to what we call rationalize the bottom anyway. So I'm going to kind of skip that and just say if there's a radical, the problem on this is a radical 20. Well, the thing is, if I multiply this by radical 20 times radical 20, this is saying what's the square root of 20? So what do you multiply by itself to get 20? Whatever that number is, now multiply it by itself, because here it is again. So radical 20 times radical 20 is 20. Kind of like a radical 5 times radical 5 would be 5, or let's maybe an easier one, a radical 4 times radical 4. Well, the square root of 4 is 2. I say 2 times 2, I get 4. I get the number back. So on this one, I'll multiply the bottom by radical 20. So this is going to be 5 times, this is actually 20. This equals 20, these two. So 5 times 20 is 100. Problem is, I just changed the fraction. So whatever I do to the bottom, I got to do to the top. So I got to multiply the top by radical 20 also. Okay, so this is going to be, and I'm just going to write like this. Instead of saying, because this would be, what, 300? Well, radical 300 is going to need simplified. It's going to need factored. So I'm just going to say radical 15 times 20, and I'll take 15 and 20 from there. So we'll kind of do some factoring from there. So we'll say 15, 20, and this is 3 times 5, 4 times 5, 2 times 2. So look for pairs here. So I got a pair of 2s, I got a pair of 5s. So on top I could pull a 5 and a 2 out. Well, 5 times 2 is 10. 10 radical 3 over 100. This one here, I can reduce the 10 and the 100 because they're whole numbers. They're rational. They're not under a radical. And they're being square rooted. So this one I could actually reduce. So this would just be radical 3 over 10. Nobody really questioned the 3 and the 100. Maybe I'll go back to this step and say some of you might have looked at the 20 and the 100 and said, I can reduce that. 20 and 100, that'd be 1/5. But this isn't 20. This is the square root of 20, which is like 4 point something. 4.4, 4.5, I don't know, 4.6, somewhere in that area. This isn't actually 20 if it's under a radical. This isn't actually 3. It's like 1.717, I think. One of those weird things I have memorized from when I was in school. But the square root of 3 is not 3. It's 1.7 something. Okay, so when we do the reducing, make sure they have to both be outside the radical or both be inside the radical. If they're both inside the radical, you can reduce. But let's see here. So this guy here, I could multiply it by the square root of 100, but what is the square root of 100? That's 10. So if you see it's a perfect square, go ahead and square root it. Don't waste your time with that. So now I've got radical 8 over 10. Let's just do some simplifying because radical 8 is not simplified all the way. 2 times 4, 2 times 2. See a pair of 2's, so it'd be 2 radical 2 over 10. This 2 reduces the 10, that 2 does not, because that's not 2, that's radical 2. I can't remember what that is, 1.414. So this is 1.414, that doesn't simplify with, or doesn't reduce with 10, but this 2 does simplify with 10. So 1 and 5, so it'd be radical 5 over 2 is my answer. Okay, this guy here, that's not a perfect square root, so don't square, or it's not a perfect square, so don't square root it, but I'm going to multiply by radical 6 over 6. I'm sorry, radical 6 over radical 6. This would be 4 radical 6 over 6, because square root of 6 times square root of 6 is 6, it just, the radical goes away, you multiply by itself, and then the 4 and the 6 would reduce. Now this 3 and that 6 do not, because again, this is not 6, it's the square root of 6. Okay, so 2 point something, but it's not divisible by 3, or reduced with 3. Okay, down here, let's keep going with this. So I've got radical 10x cubed y, and this is radical 10x cubed y. So on bottom, it's just going to be 10x cubed y. So the bottom is kind of the easy one. On top, I got 2 times 10. Well, if I think of it that way, well, let's just write it all down and we'll simplify it later. So 2 times 10 is 20. You could leave it as 2 times 10 like I did up here. I just left it as 15 times 20. And then x to the 4th, y. And now let's simplify that top. Well, 20 is 4 times 5, 2 times 2. Pull a 2 out front, so it'd be 2. And then there's a 5 stuck inside. X to the 4th. If I take the square root of x to the 4th, it's x squared. We're saying for every pair, pull one out. Well, it's going to be x squared. No x's left underneath. The y, nothing's going to come out. On bottom, 10x cubed y. Now do some reducing. So 2 and 10, those are definitely outside the radical. They can be reduced. X squared and x cubed. 2 of these will cancel out 2 of those, and there'll be an x left over. So I've got, the only thing left on top is 5y. And on bottom, I got 5x, xy, right? 5xy, yeah. Okay, it's getting kind of long, so I'm going to go down here. I want to try this guy out here. What happens if it's not just a square root on bottom? What happens if it's a cube root? Okay, so it's cube root of 9. Now, first off, the cube root of 9 is not a nice, neat number. Some people say, well, 3 times 3 is 9. Cube root, it's 3. So, but 3 times 3 times 3 is 27. So be careful on that. So when it's a cube root, well, multiplying by the cube root of 9 is not enough, because the cube root of 9 times the cube root of 9 is not 9 yet. Square root, you have to do it twice. Cube roots, you got to do it 3 total times. So 1, 2, 3 times. I got to do it 2 more times to get it. So cube root of 9, cube root of 9. And now, what times itself 3 times equals 9? Now multiply by itself 3 times. Well, that's 9. So if it's a cube root, it has to be done 3 total times. If it's a fourth root, it's got to do 4 total times. Now up here, these are all cube roots, so I can do this. I can multiply. It'll be 7 times, and I'm going to factor 9 as 3 times 3, and then that 9 is 3 times 3. So I kind of did my factor tree while I was multiplying together. Any group of 3 can come out as 1. So these 3 will come out as 1, so it'll be 3 cube root of 21 over 9. And this 3 and this 9, they're both outside the radical, so they can be reduced. So cube root of 21 over 3 would be the answer. And if you just want to double check that, type that in the calculator, type this in the calculator, and they are the same decimal value, so you know you have it right. Let me go back to number 5. I will tell you that I'll give you the answers to these. Let's see. This would be, just if you want to check yourself. And then this guy is radical 6 over 6y. Boy, a lot of that simplified. You didn't realize that probably. I didn't, at least when I looked at this. I didn't think it would simplify that. So anyway, let me know if you have questions.